So if we find our derivative gives us a gradient function. And that equation that we get when we find our derivative is an equation to find the slope of any tangent line anywhere on that curve. So one of the typical questions that gets asked is, if you have a curve and you pick a specific point on that curve. So here if I have an x cubed graph and I pick this point right here, what's the equation of that tangent line at that point? So I could draw that tangent line. And what's the equation of that line? And it goes back to grade 10 math where we find equations of lines. With equations of lines, you need two things to find them. You need the slope and you need a point. So if they give you the point, that's going to be right there. And to get the slope, you're just going to have to use your derivative, because your derivative gives you the slopes of every tangent line. And if you want to find a specific one, you find the slope of that specific tangent line by plugging in whatever x value you have into your gradient function or into your derivative. Now, that green line is called a tangent line. A normal line is the line at 90 degrees to the tangent. So we're going to find out equations of tangent lines and equations of normal lines in this next section. So how do we do that? Well, you find your derivative, and that's going to give you all of your slopes. Once you've found your derivative, you can plug in the specific x value into that derivative to find that specific slope of that line. Then you can either use the point slope formula, y minus y1 equals mx minus x1, or your slope intercept formula of a line to find your equation. Both of them require that you plug in your m value and a point. In the point slope formula line, once you plug in m and your point, you just need to rearrange it and you've got your equation. In your slope intercept form, you plug in your slope, you plug in the point for x and y, and that helps you figure out what b is. And once you've figured out b, you've got your equation of your line. So here's our first function. And underneath that function, I wrote it in function notation as well. So we want to find the equation of that line at x equals 1. So to start off, we'll find our derivative, because that derivative tells us the equation to find any slope at any point. Where are we concerned at finding it? We want to find it at x equals 1. So if we plug in 1, we know that the slope of our particular line is 4. Again, thinking, what are the two things that I need to find an equation of a line? I need the slope and I need a point. My derivative just gave us the slope. We know that it's 4. What point does this one go through? It's going to be 1 comma something. How do I find that something? Draw a little picture of it off to the side. 2x squared plus 3, does that make sense that that is a parabola like that? At x equals 1, we've got this point here, and this is our tangent. And we already know that the slope of that line is going to be 4. How do I find out what that point is. I know it's going to be 1 comma something. How do I find that something? Yeah, we can just put x equals 1 into our original equation. Because that's how you'd find a point, any point on your graph. And when we do that, we find out that this point was 1 comma 5. And that point is exactly where that tangent touches that curve. So now that you have a slope and a point, you can plug that into, right? Here's your slope-intercept, or point-slope, sorry, equation of a line. You can plug in your slope and plug in your point and simplify that. And you find out that that equation is 4x plus 1. If you would rather use y equals mx plus b, we know that our slope is 4. We can plug in our point when x is 1, y is 5, and use that to solve for b. Subtract 4 on both sides, and you get b equals 1. Working that way, now we can write our equation.
Just a reminder to all grads that GradWare as well as Grad Photo sign up is in the west hallway right now. Thank you.
The last thing we have here is just a picture from a graphing calculator of what happened. So I've graphed the parabola, which we did in the picture above, and graphed the line into y2, just so that you could see what's happening. So when finding the equation of a line, you can either use the point slope form, which is here in the green, or y equals mx plus b. They both work about equally. It's just a matter of preference. Sometimes one has more fractions than the other, but for the most part, they're very similar. So whatever you feel more comfortable with, you can use that. So the next couple of examples are just some more, so I'll give you some time to work on those. So how did you guys do on this one? Generally okay? A little bit hard without the calculator with the 4 to the 5, but so if we graph this to have a look at what it would look like, there's our original function, our point, and our tangent line. So try the next one. So here is just the graph to example 3. And if you drew the horizontal line at y equals 8, you would hit this point, and there would be one tangent here and one tangent there. Now, we need to find out where those two tangents intersect. In order to find out where those two tangents intersect, we're first going to have to find out the equations of those two tangents. So here's our first one. Did you get y equals 8x minus 8? Yep. This is example 3 still. And for the second tangent, did you get y equals negative 8x minus 8? Now, at this point, the question becomes kind of simple, because those lines both have the same y-intercept, so you can find out where they intersect just from looking at the equations. If we had something that didn't work out that nicely, how do you solve for two lines when they intersect? You have a system of equations. So you either have to use substitution or elimination to find out where those two things intersect. But this one is easy enough because the equations show you that they have the same y-intercept. So the point where they intersect, point P, is 0, negative 8. So if we're rewording this a little bit, we want to find the equation to the tangent to this at x equals 4, and another one that is parallel to the tangent at x equals 4. And they tell you the y point this time, so we've got the coordinate already. If they just said find the equation of the tangent, that would be your general derivative. Finding the equation of a tangent and they didn't specify, then they want the entire derivative equation because that's your gradient function of all of your tangents. So this one's fairly straightforward at the beginning because at x equals 4, they've already told you the point is 4, negative 21. So we can plug in our slope and our point into the point slope form, and we get our equation. If we drew a picture of this or took a picture from our calculator, it looks like that. Looking at that cubic function, can you see that there's probably another tangent somewhere that would have that same slope? So if I trace over that slope here, maybe in green, and I move this along, tell me if you ever think that, I think it'd have to be maybe, maybe right there? Looks like there's another point where that slope would be the same. How do we do that? Well, it's a trend, but how do we know where that is? How do we know what if I want to find the equation of that green line, because it says find another one that's parallel to that one, what are the two things that I need for an equation of a line? I need the slope. Well, that's easy. I know that the slope of this one is also 11. But I need a point. How do I find this point? If we know the slope of that green line, we can plug that into our tangent formula, right? When we found the derivative finds the slope of every single tangent. And if we put 11 in for the derivative, we have to solve this quadratic equation. One of the answers is 4, which we already knew. But when we move it over, make it equal to 0, and factor and solve, we find out that the other answer is negative 2. Plug negative 2 into our original equation, and we get the point negative 2, and it is symmetrical at 21. And then we can find the equation of our tangent line for that second one.